Hello and welcome to Chapter 7, Setting Up a Local Network. So remember, I'm going to ask you to take a few notes so you can submit them as homework. All right, let's get started talking about lanes. Networks are generally broken down into 4 categories. I want you to write these down. All right, so here's the first thing I want you to write down. PAN, which stands for Personal Area Network. This is the Bluetooth, which is really the IEEE 802.15, or the Wi-Fi, as long as you are, the Wi-Fi 802.11, and as long as you are in the home and you're doing peer-to-peer, that's considered to be a personal area network. The other category is the LAN, the Local Area Network. This is primarily the wireless Ethernet 802.11 or the Ethernet 802.3. That's wired. So you consider a LAN is if everything is within a building or a campus. The third one is the metropolitan area, the MAN. That's really the example of that is the WiMAX, the 802.16. As long as you are within the city limit, that is what's considered to be a metropolitan area network. A WAN, on the other hand, the wide area network, is when you are connecting LANs that are in different geographic areas, like the internet, very far away from each other. All right, the IEEE, I want you to know them. The IEEE stands for Institute of Electrical and Electronics Engineers. They house all the standards of the personal area networks, the local area networks, and the metropolitan area networks under the 802 dot series. So when you hear the word under 802, that means that's the standard within the IEEE. So you can actually go to the IEEE and you can ask for 802.3. You'll be asking for all the standards and how the Ethernet 802.3 works. All right, so you've heard of the 802.11, that's the wireless, and so on. All right, how does a LAN connect to the internet? So let's discuss that. A PC sends the data with a private address to your router. Let's say you're at home. The router is going to translate that private IP address that you have at home to a public one and hands the packet to the modem that you have at home to place on the data medium. The data medium is the cable. And that data is sent to the central office, the ISP. ISP stands for the Internet Service Provider, whoever your Internet Service Provider is. Then the ISP is going to take your data, your packets, and place them onto the Internet. All right, so here are some networking technologies that you should be familiar with and their maximum speed. But I want you to understand the following. So this way now you have to be a little bit more technical. You need to be able to differentiate between what is bandwidth and throughput, and sometimes they call them goodput, but we don't have to worry about that. Bandwidth, I want you to write the following down. Bandwidth means the maximum speed limit. It's like a speed limit on the highway. That's the maximum you can go. Throughput is the actual speed. So if the speed limit on the highway is 70 miles an hour, that's the bandwidth. If you were traveling at 35 miles an hour, that's your throughput. Why are you going 35 and not at the maximum speed? Because there's traffic. So your throughput is what the actual speed is. Latency is delay, propagation delay. How long it's taken for the data to get there. So if you're delayed an hour, that's latency. All right, so look at the table 7.1. That's always a good table to look at. Keep track of in case you are asked about maximum speed depending on the type of technology. These are for wired and wireless technologies we're talking about here. All right, so let's discuss some of these. DSL, which stands for Digital Subscriber Line, that uses the old telephone wires to get you data and voice traveling on the same telephone, plain old telephone wires. Typically, they are slower than cable, but there's no video, so you're only getting data and voice. All right, cable, on the other hand, is a broadband, always up and running, You can get voice, data, and video on it on the same coaxial cable. Cable modem converts the digital signal that takes from your PC, let's say, and converts it into an electromagnetic wave and places it on the coax cable. Then you got fiber. Fiber is also a broadband that brings your fiber all the way up to your home. Also, it transfers data, voice, and video on the same fiber optic cable. It's faster than cable broadband, but it's a little bit more expensive. Verizon Fios is an example of this. Then you got satellites. Satellites are, let me see. Yeah, satellite is high speed for those who don't have any other choice. Let's say you're living somewhere and there is not even dial-up. You're probably the only way to get there, to get any internet, is to go through satellites. Then you got, of course, dial-up. Dial-up is the slowest of all. You need to dial up to a server to get connected. You need to use your old telephone. It's all analog, the plain old telephone system. It uses a modem. The word modem, M-O, stands for modulation, which means that you're converting the digital data to analog so you can place it on the telephone wire. And the DEM in the word modem means demodulations. That modem has to be able to demodulate signal, excuse me, pick up the analog signal from the telephone wires and convert them back to digital. All right, then you got the cellular WAN. The cell WAN, this is where you got the 4G, the fourth generation, the GSM and the CDMA, the LTE, the long-term evolution, and the WiMAX. So this is typically for outside. It could be most likely a metropolitan area network, all the cell WANs, even though most of them are MAN instead of WANs. All right, so most laptops, by the way, most laptops and mobile devices have integrated broadband modems. I don't know if you knew that or not. All right, cell phone tethering. The cell phone connects to a cellular network and provides communication to the tethered device. So let's say you lost your ISP connection on the internet. You can convert your phone, switch your phone to 4G, and you can connect the internet through your phone. Your phone will be your hotspot, for example. That's what really tethering is. You can also have an external USB broadband if you wanted to. You can have your own, what did I say? Oh, you can have your own USB broadband. Did I say that? Yeah. All right, so connecting a PC to a local network. So where are we right now? I'm losing track. Yeah, so connecting a wired network. So if you are going to use a wired network in a wired LAN, you want to use a straight through cable with an RJ45 connector, as you can see right here. And that connects typically to an Ethernet NIC that has the RJ45 connection. For a wireless connection, you want to click on the network icon that's on the bottom right here, and on the taskbar to select for the wireless network that are available for you. I'm sorry, not that one. Right. Where are we here? Right here. So if I connect right here, you can actually see all the networks that are available. All right. Continuing on. Creating a VPN. So that's where we were. What is a VPN? A virtual private network is the one that's going to allow you to communicate with another device across the internet securely. And if you were connected peer-to-peer, as if you were connected peer-to-peer, you can create a free VPN connection using OpenVPN, by the way. Just go to openvpn.net for more information. You'll be able to do that. We'll discuss that when we're talking about, I think, in the next chapter. We'll be able to set this in the lab. If you take the NTWK 290 class, the ethical hacking course that we offer in the fall, you'll be able to set up VPN, proxy chains, a whole 9 yards, and you'll be able to get into the dark net and so on. Anyway, creating a dial-up connection. All right, what happens if you ever need to do that? You install an internal or an external modem and have and go to the device manager. Make sure that the device manager recognizes it. Plug in the telephone RJ11 wire to the modem and go to the network sharing center in Windows 10, 8, or 7 to complete the installation. And by the way, you really have to do that anyway. So all of this is in your book. You can follow this step by step. All right. So that's creating a connection. Let's talk about dynamic and static IP configuration. All right. To be able to communicate with any device in a LAN, a device needs an IP address. What is an IP address? An IP address represents the network or the area the host is in. Something that is analogous to a house in an area zip code. So the house is the device, the house number is the MAC address, is the device, and the zip code is like the IP address. Assuming that the house can move from one zip code to another, so every time the house goes from one area to another, it belongs to a different zip code, a different IP address. All right, here's something that I want you to write down. Devices automatically search for a DHCP server to request an IP address for the network that they are in. All right? You may assign a static IP address to a device instead of having it look for a DHCP server. So if you don't want to look for a DHCP server and you want to use a specific IP address, then you type that in. That's called a static IP address. And to do that, you would have to go to the network sharing center. And I'm not going to do that here, so I don't have to change it. And then you type that address in. We'll do that in class. That's not a problem. All right, here's another thing I want you to write down. An IP address identifies who you are in the network. A subnet mask address, also write this down, is used by devices to mask the host portion of the IP address, revealing the network portion. The default gateway address is, also write this down, is used to enable the device to send data outside the LAN. So make sure you know, because what the DHCP server gives you is the IP address, the subnet mask address, and the default gateway address. Make sure you know that. All right. Write this down also. What is the MAC address? A MAC address identifies the host in the LAN. Devices that are connected directly to each other will use the MAC addresses to communicate with themselves. All right, so you should know now the difference between an IP address and a MAC address. IP address identifies the area, the network you are in. A MAC address identifies who you are inside the LAN. All right, so a hotspot, by the way, so let's just move on. I know we talked a lot of your NIC, where is the MAC address is located. And so now let's talk about the hotspot. A hotspot is an ISP. By the way, a hotspot ISP can use a MAC address filtering to find out who you are, because the MAC address is unique and no one else in the world will have the same MAC address. So get a MAC, they'll use your MAC address to find out who you are and allow you to get on the internet. Now, to find out what your MAC address is, all you have to do is type in the word ipconfig/ALL, and that will automatically give you your IP address. So if you type CMD right here, and if you go and you type ipconfig/ALL, and ipconfig/ALL, and if you hit enter, you'll see where is my MAC address. There's my MAC address, the physical address. It's written in hexadecimal number. And you will see that when we get to hello. Okay. So, oops. Sorry about that. The MAC address is right here. All right, that's it for this video, and I'll see you on the next video. ipconfig all, right? That's all you need to type.